All right, we'll do another review of a word problem, and then we're going to learn something new as well. So Upgen Manufacturing estimates that its weekly profit, P, in hundreds of dollars can be approximated by the formula P equals negative 5x squared plus 10x plus 6, where x is the number of units produced per week in thousands. So, graph it on the calculator first, then find your important points. We found our zeros at negative 4.5483, 0, and 2.48, 0. Y-intercept is 0, 6, and the maximum is 1, 11. So I put those in there. Again, x is units produced per week in thousands. Y value is the weekly profit in hundreds of dollars. The vertex is 1, 11. The zeros we just saw. Y-intercept is 0, 6. And I guess let's look at what makes sense for the domain and range. So we're talking about x is units produced per week. Well, can we produce negative something? Of course not. So the lowest value we can produce is 0. We can produce 0 something. We just don't make them. So it's a bracket on 0. And then, again, x is left to right. So as we go across, as we go from here to here, after this point, all our y values are negative, and I can't have negative y values. Remember, I really want to stay in my first quadrant because those are positive values and we're dealing with word problems now. So our x value goes from 0 to 2.48 because after 2.48 we're below the y-axis and we have negative y's and we can't have that. So it's 0 to 2.48. And the y is really hundreds of dollars. So technically it is 0 to 2.48 hundreds of dollars. So $248 is our domain. Our range, well, again, you can make $0 up to our maximum, so 0 to 11. But again, the y is in hundreds of dollars, so it's actually 0 to $1,100. So notice that we don't have infinities anymore like we did before. We don't have infinities because we can't have negative numbers a lot of the times when we're dealing with word problems. So if we look back at our problem, we didn't answer this yet. If the company produces 0 units during a week, how much profit will they make? Well, 0 units means x equals 0, and they want to know the y, because that's the profit, so they're asking for the y-intercept. Well, we already had the y-intercept, 0, 6. But at 6, again, is in hundreds, so it's $600. So even if you produce 0, we get $600, which is nice. I don't know how we're doing that. Maybe we're robbing somebody, but either way, we make $600. The next one, what is the maximum profit the company can make? Maximum profit, if we're talking about maximum, it's got to be the vertex. Profit is the y, so our y value for the vertex is 11. And again, it's hundreds of dollars, so $1,100 is the maximum. How many units have to be produced to maximize the profit? Well, again, we're talking about maximizing, so what's our vertex? But how many units? Well, we're talking about the x, so the x value of our vertex is 1, and that's in thousands of units, so we have 1,000 units. So again, do what you've normally done, find the zeros, the vertex, and the y-intercept, and then here, figure out if they're asking for x and y, and if they're asking for a vertex, a y-intercept where x equals 0, or a x-intercept, a 0, when y equals 0. And we'll see some of those as well. Alright, now the next type of problem we're going to see is if we have, well, write an equation of a quadratic function in standard form, vertex form, and factored form that has a vertex of 3, 2, and goes through the point 11, negative 30. Well, if it has a vertex of 3, 2, that's our h and our k. and it goes 311, negative 30, that's just an x and a y. Well, if we have our vertex, h and k, and x and y, what form do we want to write it into? Well, vertex form, because it has the vertex in it. Now we plug in everything that we have. F of x, or y, is negative 30, equals a. We don't know a. That's what we have to figure out. That's the whole point of this problem. So we plug in what we have to find a. Then x is 11, h is 3, and it's minus 3 squared, plus k, which is 2. And now we just solve for a. Order of operation tells us we do inside the parentheses first. 11 minus 3 is 8. Then exponents, 8 squared is 64. I just put it in front of the a. It could be a 64 just as easily. Well, I need to get a by itself, so the first thing I have to do is get rid of this 2, so I subtract 2. So I get negative 32 equals 64a, and to get rid of the 64, I divide by 64. Now 32 can't be divided by 64, but it can be reduced as a fraction, so it's negative 1/2. So now I can plug it into vertex form. F of x equals a, negative 1/2, times x minus h, which is 3, squared, plus k. So I use my h, k, and a, but not x and y, because our equation has an x and a y, or an f of x. Now if I want to put that in standard form, I just multiply this out. So a lot of what I've been seeing us do, we put this thing in brackets. X minus 3 squared is x minus 3 times x minus 3. So we're going to FOIL. X times x is x squared. Negative 3 times x is negative 3x. X times negative 3 is negative 3x. Negative 3 times negative 3 is positive 9. Add up my like terms. X squared minus 6x plus 9. Then I distribute the negative 1/2. So negative 1/2 times x squared is negative 1/2 x squared. Negative 1/2 times negative 6x is positive 3x. And negative 1/2 times 9 is negative 4.5. Then I have to add in the 2, the last step. So I get negative 1/2 x squared plus 3x minus 2.5. Not a very nice whole number there, but that's okay. Then to put it into factored form, well, I need the zeros. So if I looked at the table, I can see that 1 and 5 are zeros if I put in the equation, either this form or this form. Or I can graph it and see the zeros as well at 1, 0, and 5, 0. So my zeros are 1, 0, and 5, 0. I always start with my a, just like every other form, so negative 1/2. And then inside my parentheses, I have an x, just like it did here, just like it did here. And inside is the opposite. So a 0 of 1 gives me x minus 1, and a 0 of 5 gives me x minus 5. And I have all three forms of a quadratic just based on a point and a vertex.